points, lines, and planes is this section, okay, which, again, chapter 1, section 1, and like I said, lots of vocab in this section. So we're going to talk about things like a point. A point is a single dot. It's the simplest figure in geometry. We name a point by a capital letter. So if I were to just say A, you should know that that is a point. Okay, I don't have to write the word point A, I can just write A. And all geometric figures consist of points. So everything that you can build consists of points. And a point has no dimension. We're going to talk about dimensions, like one dimension, 1D, 2D, 3D, that kind of thing. A point has none. It doesn't extend in length. It doesn't extend in width. It doesn't extend in height. It's just a simple dot. Okay, a line is next. And a line is a geometric figure consisting of at least 2 points. So you need at least 2 points to form a line. And it extends in 2 directions, so that's why it's considered to be 2D, okay? Without ending. And it's named by 2 points or a single lowercase letter. So it will either be called line AB with the word line. It will be called AB with a little line with arrows on top of it. Or this little lowercase italicized usually, or cursive letter. It can also be called line L. And a line has 2 dimensions. No, just kidding. A line has 1 dimension. It just has length. Getting ahead of myself. Okay. A line has 1 dimension, so it just has length. Just extends. Okay, next one's a plane. So we're building. We went from points. Points form a line. Lines form plane. Okay. So a geometric plane is suggested by a floor, wall, tabletop. So we say, like, when we're picturing a plane, I would say, like, this front wall could be a plane. This floor could be a plane. This ceiling could be a plane. Okay? But really, it does not have an end. So you have to picture a plane to have no ending. If it could expand in space and never end, okay, that's what a real plane would be. It doesn't have edges because it doesn't end. But there's no way to draw that in a book. So although it really has no edges, we show a plane as a rectangle or a parallelogram or something of that shape. It's named by a single capital letter or 3 more points that it contains. So if you've got a letter like M is floating kind of there, then I can name this as plane M. I can also have a plane that's got A, B, C, D, where the sides meet. And I can call this plane A, B, C. I could call this plane B, C, D. Any combination of those letters would also name it, but it's got to have at least, it's either one single one like that M floating on the inside, or if you're going to use where the points meet or points that lie on the edges, then it's 3 points. Okay, space, collinear and coplanar. Some additional vocab. So space is a set of all points. Collinear are points that lie on one line. Non-collinear are points that are not on the same line. Coplanar, points that are on the same plane. and non-coplanar points that are not on the same plane. So if I asked you if points were on the same line, so let's say I had a line, okay, and I had A, B, and then I had C not on that line, okay? So A and B would be collinear, right? They both lie on the same line, okay? I can even make a line through B and C, and I can now say that B and C are collinear. I can do the same to A and C, and A and C would be collinear. But A, B, and C can never be collinear. The three of them cannot lie on one line, right? There's no straight line that I could take and put through A, B, and C. Does that make sense? Okay. All right, intersections, next vocab term. So to intersect means to meet. If you think about like intersections on the roads, right? It's where two roads meet or two or more roads meet. Okay, so intersect by definition means to meet or cut through. The intersection of two figures are the set of points that are in both figures. So a line and a plane can intersect. Two lines can intersect. Two planes can intersect. And then the dash is in the diagram. So what's really hard, especially in geometry, is that you're going to get a ton of three-dimensional figures. And part of the hardest point is you're looking at a three-dimensional figure on a two-dimension page. So sometimes it's hard to see what that three-dimension would look like if it was in space. So dashes are the part of the diagram that would be hidden from view if that was a solid object, okay? So if you could picture this little image, this would be a plane, okay, with a line running through it from top to bottom. So line N would be like if I could take my stylus and I could put it straight through the top of my iPad. Let's picture that my iPad is the plane. This is going straight through it, right? What you wouldn't see if I had my iPad tilted this way, you wouldn't see the back part of this. You with me? Because my iPad would cover it. That's the dash line, okay? The M, line M, which is running, literally would be if a line was sitting on top of my iPad. You would see that whole entire line because nothing's blocked from view. Does that make sense? Okay. So think about all the things we've already talked about, how we could name these things, and notice that how they're named. This one could be line N, or it could be line QP, or it could be line PQ. Okay? So I could say this is QP. I could say this is PQ. Okay? All of those would be the line like if I took a pencil and put it right through a piece of paper from top all the way through it. Okay? And then think about this line. So this line here could be called what? Give me an example of what it could be called. Go for it, Fernando. Line M. What else?
PT.
Line PT. Good.
Line SP.
Good, Reagan. Line SP. All of those are examples of what I could call them, okay? And then this tabletop looking thing, which is really a plane, right? What's one way I could name that plane? Plane R. Good. So R, notice R is not a point that is on the edges. It doesn't have a dot. That's the name of the plane. So that could be called plane R. Okay? And then all the other points that are on it are ways that I could name it too, but I have to pick three of them. I could say VSP. I could say STV. They don't have to go in any specific order. I could say plane I said VSP. VPS, okay? Anything like that would also name your plane. Questions so far? Anybody still copying that down? All right, segments. So segments are lines that stop, okay? So think about a line has arrows. A line never stops, okay? A segment does. So a segment, like segment AB, can be written as the word segment AB, or it can be written as AB with a line, no arrows this time over it. It consists of all the points A and B sorry, it consists of points A and B and all the points in between A and B. And the order of the letters is not important. So segment AB is the same thing as segment BA. Oh, it already has the word. And then A and B are called the endpoints of the segment. So what's the difference between line AB and segment AB?
Line AB continues.
Good. Line AB would be the whole thing, arrows pointing in each direction, unending. And segment AB is going to start and stop at A and B. Can you measure a line? If I asked you what the length of a line was? No. Why?
Goes on forever.
It doesn't end, right? Can you measure a segment? Yeah, good. Okay, and array, like the combination of the line and the segment. So array, which again can have the word ray, AB, can be written as AB, and notice this time the little symbol above it has one endpoint and one arrow. It starts at point A and continues on unending in the direction of B. So whichever letter doesn't have the arrow is your end point, and whichever letter does have the arrow is the direction the arrow points. Now this is the first time the letters matter which order you put them in, because ray BA means that B is the end point and A gets the arrow. Can you measure a ray? No. Again, doesn't end. Okay, opposite rays share an endpoint and point in opposite directions. They can't be overlapping because they have to share an endpoint. So in this little diagram, ray BA and ray BC are opposite rays. They both have B as an endpoint, but one point's right and one point's left, opposite directions. So what could you assume that two opposite rays form? A line. Good. All right, so let's test our knowledge, okay? This is the first type of question you might see. So they might actually, the homework's going to actually ask you to draw some stuff too, to the best you can, okay? I don't care if they're the sloppiest drawing, as long as they meet like what they're asking for. But it's also going to ask you questions like this. So true or false, okay? Line PF ends at point P. False. Why? A line doesn't end. Good. Okay. So it doesn't ask why, but if it did, that's what I would say, something like that. Okay. Point S is on an infinite number of lines. What does infinite mean? Like not ending. So it could be 17 lines. It could be 800 lines. It could be, right? So if I put a point on the board like this, and I asked each of you to come to the board and draw a line that goes through S, could they all be different? Yeah. So this is true. As soon as I add a second point, there's going to be only one line, right? If I said this is S and this is T, and you can draw every single one of you, the length you draw it might be different, but it's still the same line, right? Because the line doesn't end, and technically the length wouldn't matter. All right, so 3, a plane has no thickness. True. 4, collinear points are coplanar. Let's picture that, right? So if they're collinear, if I've got A, B, C, and I drew a plane around that line, would they all be on the same plane? Yes. So the other way around may not be true. Because if I had done this, and I said A, B, and D are coplanar, right? Because I can definitely draw a plane around them. A, B, and D are coplanar, but they are not necessarily, they're not collinear, right? Okay, does that make sense? So if they're collinear, they're coplanar, but not necessarily the other way around. 5, planes have edges. False, they do not have edges. 6, 2 planes intersect in a line segment. So let's picture this one. Oh, I just, whoops-a-daisy. What did I just say? I've only used like 17. Okay, so 2 planes intersect. So let's think what a plane, if that's a plane, and then maybe I've got another plane that's intersecting it this way, okay? And if you could picture that these would cross at something that looks like that, right? Think about the 2 sides of a box, okay? Where do they meet? What's it look like? What kind of shape would be the edge of a box? So 2 planes are going to intersect at a line, not a line segment, okay? Because the planes don't end. So this is false. And 7 says 2 intersecting lines meet at exactly 1 point. A little bit easier to draw, right? What do 2 lines that would intersect look like? Something like this. And how would I describe where those 2 lines meet? Has a point, so this is true. Can a line double back and hit at another point? No, it's not a curved line, right? We're talking a straight line. It's only going to hit at 1 point. Number 8 says points have no size. Can you measure a point? No, this is true. And number 9, line XY can be noted as XY with the arrows on top or YX. True. Remember, the order of the line doesn't matter. The order of a segment doesn't matter. When it matters is what? Good. Array. All right. Now you've got a figure. Okay. So sometimes you're gonna get pictures and sometimes you won't. You gotta picture things in your head. This says given planes M and N, use the diagram to classify as true or false. So N is my vertical plane. M is my horizontal plane. Okay. Number 1 says point P is in M. So where is point P? On the bottom there, on the vertical plane. Is that on plane M? No. So this is false. B, which if it's a lowercase italicized letter, what is it implying? A line. Okay, so that's saying line B is in M. Is this line in that horizontal plane? Yes, so that's true. 3, line XY contains P. So a single capital letter is what? So this is where it's a little tricky. A single capital letter like that is a point. Okay? So does line XY contain P? No, that's false. Number 4, M, which is now talking about plane M, contains line YX. True. 5, A, which is now talking about point A, is on lowercase b, which is line B. True. 6, A and P are in plane M. Point A, correct. Point A is on it, but point P is not. So this is false. And number 7, N contains point P. So plane N contains point P. True. Very good. Any questions on any of those? Okay, now you get to experience the sketching part, which is not always the easiest part, and yet can be the most fun to grade because some of y'all pictures will be very interesting. All right, so A says sketch a plane and a line that is in a plane. B says sketch a plane and a line that does not intersect in the plane. And C, sketch a plane and a line that intersect the plane at a point. So go ahead and see if you can draw each of those different things. All right, so your drawings can look something like this. Doesn't have to be exactly this, okay? But A said sketch a plane and alignments in the plane. So you wanted to draw some sort of four-sided figure, which again just represents a plane, but technically that would be unending. And then you wanted to draw one line running in it, okay? So in this example, it's plane M and line L, okay?
Does it have to be from end to end?
No, because it's a line, it's gonna extend. Yep, so as long as it's laying, like almost like if you could picture a pencil laying on top of a piece of paper. If it looks something like that, that's what you'd have. Okay, B says sketch a plane and a line that does not intersect with the plane. So your plane needs to be running in some way so that the line would not be running it. So it could be on top of it or below it, to the right of it, going in a different direction, that kind of a thing. And then C says sketch a plane and a line that intersects in the plane at a point. So this time we don't want the line resting on the plane, we want it intersecting it as though I would take a dart and put it through a piece of paper, okay? So my rule on drawings is you need to at least try it, even if it's a total mess, okay? At least make the attempt, yep.
Do you need to make the dash line?
So, no, I'm not gonna go that far. The question was, do you need the dash lines? No, I don't need them. I can usually figure out what you're trying to imply, yeah. Okay, now sketch two planes that intersect at a line. So now you've got two-dimensional figures. Okay? These are just like little tips on how to do it. If you draw a vertical plane, so one that runs like from the top to the bottom, and shade it in. So my recommendation would be to use your highlighter, shade it in a color, okay? And then draw a second plane that's horizontal, so one going up and down, one going left and right, and shade that a different color. And then use the dash line to show where the plane is hidden. And then draw the line of intersection. So your goal is to get it to look something like this. So as far as homework goes, because tonight's your first homework, okay? It should be on your to-do list. If it's not, if you got something going on, let me know. There's not a ton of work to do in this. It's not like we're getting into like algebraic issues or problems where you have to work step by step out. So just make sure you read the directions carefully. If it's a true or false, put a true or false. But if it's a true or false and explain it, make sure you're explaining it. I'm going to look for explanations. If it's a drawing, make sure you're drawing it. I'm going to look for your drawings, okay? If you get to something that you have absolutely no idea, you may put a question mark. That does not mean you can have a homework full of 30 question marks, okay? One every once in a while is not a big deal. Especially if it's on an even, okay? On the odds, I will post the answer, so I have to like literally create it because you don't have your book yet. I'll pull the appendix, which would be the back of the book. Check your odd answers at the back of the book so that tomorrow what we can focus on is if you didn't understand one of those odd answers, I can go over it. And I can also just go over the evens to save us some time, okay?